Okay, good day, students. So this is a teaching on section 1.1 with the focus on the order axioms. So just before I start with the order axioms, just to give you an overview of where we are and what we've done. We started off with the axiomatic definition of the real numbers, which we denoted by the symbol R, with two operations, addition and multiplication, as well as an ordering greater than, so that's where we're going to focus on today, and then the 13 axioms given in this list. Now, you already covered the four axioms of addition. You've covered the four axioms of multiplication, the one axiom of the distributive law, and then today we will cover the three order laws or the three order axioms. The last axiom, the Dedekind completeness axiom, we will cover in section 1.2 next week. So just to quickly run through, we had the four axioms of addition, followed by theorem 1.1. You've seen the proof of that in a previous video. Then we had the four axioms of multiplication, followed by the distributive law axiom, which was then used in the proof of theorem 1.2. Again, you saw this in a previous video. I will then basically pick up at theorem 1.3. Now for theorem 1.3, you can read through the different statements yourself, and you will see that theorem 1.3 is very similar to theorem 1.1. Theorem 1.1 focuses on the addition properties, which is then proved using the axioms of addition. With theorem 1.3, we make use of multiplication. So when you do the proof of these statements, you will need to make use of the axioms of multiplication. Now you will see we left the whole proof as a tutorial exercise. So please do try this, proving these statements by yourself. Up to this point, you can only use theorem 1.1, theorem 1.2, the four axioms of addition, the four axioms of multiplication, and the distributive law axiom. So if you get stuck proving these statements, just go look at theorem 1.1, because you will see these statements are proved very similar to that of theorem 1.1. The only difference being is making use of the multiplication axioms. Now, before starting with the order axiom, I am going to first go to the definition below it. It says, let A and B be real numbers. Then A is called larger than B, written A greater than B, if A minus B is greater than 0. So in other words, we define larger than, A larger than B, if A minus B is greater than 0. So if you think about it, if A is the bigger number than B, then A minus the smaller number will still stay positive. Now, regarding the other three inequality symbols that you know, greater than or equal, less than or equal, each of these three are defined in terms of greater than and equality. And then once it's defined as greater than, we can make use of A minus B to get it greater than 0. Because if you look at the three order axioms, you will see each one of them requires a greater than 0 before you can use them. So if I give you any question where you need to make use of the order axioms, let's say a question involving these three inequality symbols, then the first step would be to take this inequality symbol and convert it into a larger than symbol. Your second step will be then to use this definition to convert the A larger than B into A minus B greater than 0. Once I have the format greater than 0, I can go back and I can make use of the axioms. When I'm done with the axioms, I can then change back using the first definition and these three notations to get whatever I wanted to prove. And that's exactly what we're going to do in theorem 1.4. But before I start there, let's just quickly go back to the three order axioms. So the first axiom says, is called trichotomy, and it says that for each real number A, exactly one of the following statements is true. So if you can think of any real number, it will either be larger than 0, meaning it's positive, it will be equal to 0, or its negative will be greater than 0. So if you think about a negative number, then the negative of the number that you were thinking of would make it then positive. And that's where trichotomy comes in. And then axiom 2 says if A is larger than 0 and B is larger than 0, then we have A plus B is larger than 0. This is quite easy to see. Here, 2 is larger than 0, 6 is larger than 0, therefore 2 plus 6 gives me 8, which is still larger than 0. And then order axiom 03 says if A is greater than 0 and B is greater than 0, then the product between these two will be greater than 0. And again, it's the same as thinking of a positive times a positive, which will then give you a positive. So positive 2 times positive 3 gives me positive 6. So in the next video, I am going to look at the proof of theorem 1.4.